Today, class, we will be learning the washer method, and your instructors today include Zachary Post and Ryan Howell. Today, we will be your instructors, and our subject will be all about revolutions and more revolutions. Class, let's start with the fundamentals of what the washer method is doing. So what you're going to do is you're going to integrate from A to B of whatever you're trying to find. So like if you want to make a cylinder or a hollow cylinder from 0 to 4, your A would be 0, your B would be 4. Make sense? I think it does. You guys got this. Alright, so you're going to integrate your large radius, which is going to be your outer function, to your smaller radius, which is your inner function. And that's going to be multiplied by your tiny infinite little section of x. And what this is doing is you're finding every cross-sectional area. That's why you're multiplying by pi, because you're finding the difference in each value and then multiplying it by pi, finding that little washer section. And as you multiply that by your little infinite x, you're extruding it among those values and you're getting your overall volume.
Now that we've shown you the generic formula, here's a pretty easy problem that we can show you just a quick example on how to do washer method. So we're going to write out our generic formula, and we can see that we have two different r's, and we have pi times the integral of big R squared minus little r squared. And so big R in this case is going to be root x, because that's going to be the function on top. Big R is always going to be the function on top because we're subtracting the smaller area away from the total area that the big one would have had. And so little r is x squared because it's going to be on the bottom. We're going to be subtracting that area away from the area that root x had. And so now we're going to go ahead and square both. And then we're going to go ahead and take the integral. And so while we're taking the integral, you can see we just raise the exponent and then divide by what we raised it to. And now we're going to go ahead and plug in 0 and 1 and subtract them. And our final answer is 3 pi over 10. And that is the total volume when that is revolved around the x-axis.
Now, begin a second example problem, because practice makes perfect, right? So, in this case, our big R is going to be x, and our little r is going to be x cubed. And our limits of integration are going to be from 0 to 1. So first, we're going to plug in. So we're going to get pi, the integral from 0 to 1, of x squared minus x to the third raised to the second power times our change in x dx. And now we're going to simplify that out. So we're going to get pi, the integral from 0 to 1 of x squared minus x to the 6th dx. Now we're going to integrate. So we're going to get pi from 0 to 1 of x to the third over 3 minus x to the 7th over 7. And then when we plug in our limits of integration, we're going to get pi times 1 over 3 minus 1 over 7. Then when simplified, we'll get pi times 4 over 21. So our final answer is going to be 4 pi over 21. And that is how you find the volume of two simple. It's how you find the volume of revolving two functions around the x-axis.
This is the greatest day!